The first element is hydrogen. You have to look on your periodic table to see how many electrons hydrogen has. For this exercise, we're going to assume that every atom is neutral, every element is neutral. So what that means is it's going to have the same number of electrons as protons. Hydrogen is number 1, that means it's going to have 1 electron. And that first electron is going to go right here. The rule is you have to go to the lowest available energy level, which in this case is 1s. And we're finished. Beryllium is number 4, so it's going to have 4 electrons. So you start the same way. We have 1 down here. Now you can fit 2 electrons on each level, so the second one is going to go down here. It's in the down direction, because remember, in each orbital we have one with a positive spin, that's what the up arrow means, and one with a negative spin, that's what the down arrow means. So now we've run out of space in our 1s orbital, so we have to jump up to the next available one, which is 2s. We put 1 in the up direction. We'll put 1 in the down direction. So now I have 1, 2, 3, 4 electrons, so I'm finished. Carbon has 6 electrons. We're going to start off the same way. Every single atom has the same electron configuration as the ones before it. So we start off the exact same way. So that's 4, but I need 6. So I've run out of space in my 2s orbital, so I need to go up to the next available one, which is the 2p. So I put 1 here. Now the tendency is to put the next one here, but that's not right, that's wrong. Electrons like to have their own space, so if there is an available space, they will go to that open one, just like that. They'd rather have their own seat than sit with somebody else, if possible. Neon is next. Neon has 10, so we have 1, 2, 3, 4, 5, 6, 7. Now that I've filled it up, I can go back and start doubling up the electrons. Once it gets filled up, then you can sit next to somebody else. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're good. Sodium has 11 electrons. So it's going to start off the exact same way. Every single element has the same configuration as all the ones before it. But then it gets different at the end. So that's 10. But now I need 11. So where's the next one going to go? I'm all filled up. The rule is you go to the next lowest available energy level. So that would be the 3s. So it goes right there, and we're finished. Now, and make sure when you check yourself, you got to make sure that the electron configuration makes sense. For example, take a look at sodium on the periodic table. It's in the 3rd row. It's in the s block, so I know it's going to be 3s. And it's the first one, so it's going to be 3s1. So make sure that on your Aufbau diagram, it's in the 3s orbital, and that it has 1 electron. That's what that means. It's all connected here. Everything is connected. So 3s1, 3s1, it should be exactly the same. Silicon is number 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I ran out of space, so I got to go to the next one. 13, 14. And check yourself. Silicon is in the 3rd row. It is in the P block, so it's going to be 3P, and it is the second one in, so it's going to be 3P2. So make sure that you are on the 3P orbital and that you have 2 electrons. It's all connected. Chlorine is the next one. Chlorine is number 17. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and we stop there. That's it. Calcium is next. Calcium is number 20. It's going to be exactly the same until you get to that last electron. Every element has the same configurations as all the ones before it, but you only get different at the very end. Let's see, I sort of lost track. Oh, here we go. We got 2 more. We jump up to this level, 1 up, 1 down, and that should be 20. So we can stop there. So take a look at calcium on your periodic table. It's in the 4th row. It's in the S block, so it's going to be 4, S, and it's the second one in, so it's going to be 4s2. So look at your Aufbau diagram and make sure you did it correctly. It's in the 4s orbital, and it's got 2 electrons. So yes, I did it correctly. We're all good. Next is iron. Iron is in the D block. Take a look on your periodic table. Iron is number 26. It's in the D block, so I know that on my diagram over here, I'm going to have to start moving into these D blocks over here. So let's see what happens. I have 26. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Uh-oh, what do I do now? Well, the rule is you have to go to the next energy level that's available. So what should I go to? Should I go to the 4p or the 3d? Well, look at the way it's drawn. The 3d is actually lower energy than the 4p. That's why it's a little bit lower down on the page. So because it's lower energy, that's the one we're going to go to. So we're going to go over here. Remember, you can't sit next to the other guy if there's still space available. 1, 2, 3, 4, 5. Now I have to go back and fill in 6. And I think that's it. That should be 26 electrons. Next is Se, selenium. That is number 34. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now I can go up to the 4p. 1, 2, 3, 4. Whew. So we're finished. So take a look at selenium on your periodic table. It's number 34. Find it. It's in the 4th row. It's in the p block, so it's going to be 4p. And it's number 4. 4p4. So make sure that on your Aufbau diagram you are in the 4p block and that you have 4 electrons. It should match up exactly. Rubidium. That's a heavy one. That's number 37. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Over here, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. So I ended up at 5s with 1 electron, 5s1. Take a look at your periodic table, find rubidium. It's number 37. And sure enough, yes, it's in section 5s1. So we did it correctly. We have one more, that's TinSn. That's in the, let's see, where is it? That's in the P block. I'm not going to draw all of them again, but take a look at Sn on your periodic table. It's in row 5. It's in the P block, and it is number 2. Sn is 5p2, so your last electrons should be 5p up here, 1, 2. So you should have everything before that filled in. All this stuff should be completely filled up. And then you end up at 5p2 up there. Okay? I hope this helped. I'll see you guys in class.